As stars are the brilliant beacons of the universe, illuminating the cosmos and driving the evolution of galaxies. Their life cycles, from birth to death, are processes of immense complexity and significance, influencing the creation of elements and the dynamics of the universe itself. This article explores the fascinating journey of stars, beginning with their formation in stellar nurseries, progressing through the stages of nuclear fusion, and culminating in the cataclysmic end stages such as supernovae. Understanding these stages not only provides insight into the stars themselves, but also into the very matter that makes up the world around us. The life cycle of a star begins in vast clouds of gas and dust, known as stellar nurseries or molecular clouds. These regions, often found in the spiral arms of galaxies, are composed primarily of hydrogen molecules, the most abundant element in the universe. Under the influence of gravity, these clouds begin to collapse, causing the material within them to clump together. As the cloud collapses, it fragments into smaller clumps, each of which can potentially form a star. The process of collapse increases the density and temperature within these clumps, leading to the formation of a protostar at the center. This protostar continues to gather mass from the surrounding cloud, and as it does, its core temperature rises. Once the core temperature of a protostar reaches about 10 million degrees Celsius, nuclear fusion begins. This marks the transition from a protostar to a main sequence star. Nuclear fusion is the process where hydrogen nuclei combine to form helium, releasing vast amounts of energy in the form of light and heat. This energy provides the outward pressure needed to balance the inward pull of gravity, stabilizing the star and allowing it to shine for millions to billions of years depending on its mass. The main sequence phase is the longest stage in a star's life cycle. During this period, the star fuses hydrogen into helium in its core, producing the energy that we perceive as light and heat. The position of a star on the Hertzsprung-Russell diagram during this phase is determined by its mass, with more massive stars burning hotter and brighter and residing on the upper left of the diagram. Low to medium mass stars like our Sun can spend billions of years on the main sequence, steadily converting hydrogen into helium. High mass stars, on the other hand, burn through their hydrogen fuel much more quickly, sometimes in just a few million years. The fate of a star is closely tied to its mass, which dictates how it will evolve after exhausting its hydrogen supply. As a star exhausts the hydrogen in its core, nuclear fusion slows down and the core begins to contract under gravity. This contraction heats up the core and ignites the fusion of hydrogen in a shell around the core. The outer layers of the star expand and cool, causing the star to swell into a red giant, or, for more massive stars, a red supergiant. For low to medium mass stars like the Sun, the red giant phase is followed by the ejection of the outer layers, creating a beautiful shell of gas known as a planetary nebula. The remaining core becomes a white dwarf, a dense Earth-sized remnant that will slowly cool over billions of years. High-mass stars follow a more violent path. After the red supergiant phase, their cores undergo a series of fusion reactions, producing heavier elements like carbon, oxygen, and eventually iron. Once iron accumulates in the core, fusion can no longer proceed because iron fusion consumes energy rather than releasing it. The core collapses under gravity, triggering a supernova explosion. Supernovae, the explosive end. A supernova is one of the most dramatic events in the universe. The collapse of a massive star's core creates a shockwave that blows off the outer layers in a tremendous explosion. This explosion is so bright that it can outshine an entire galaxy for a brief period. Supernovae are not just spectacular, they are crucial to the cosmos. During the explosion, elements heavier than iron, such as gold and uranium, are created and dispersed into space. These elements, scattered throughout the galaxy, eventually become part of new stars, planets, and even living organisms. In this way, supernovae play a key role in the cosmic recycling process, seeding the universe with the building blocks for future generations of stars and planetary systems. The fate of stellar remnants. The remnants left behind after a supernova depend on the mass of the original star. If the star was between about 8 to 20 times the mass of the Sun, its core becomes a neutron star, a city-sized object with an incredibly dense core where protons and electrons have fused into neutrons. Neutron stars are among the densest objects in the universe, with a mass greater than the Sun packed into a sphere only about 20 kilometers in diameter. For stars with an initial mass greater than 20 times that of the Sun, the core's collapse can result in the formation of a black hole, a region of space where gravity is so strong that not even light can escape. Black holes remain one of the most mysterious and intriguing objects in the universe, with their intense gravitational fields warping space and time. The creation of elements. One of the most remarkable aspects of the stellar life cycle is the creation of elements. Through nuclear fusion in the cores of stars, lighter elements like hydrogen and helium are fused into heavier elements like carbon, oxygen, and nitrogen, elements essential for life. The process of nucleosynthesis continues in the more advanced stages of a star's life, producing elements up to iron. The heaviest elements in the universe are forged in the intense environments of supernovae. This process, known as supernova nucleosynthesis, is responsible for the creation of many of the elements found in the periodic table, including the gold in jewelry and the iodine in our bodies. Without the life cycles of stars, the universe would lack the chemical diversity necessary for planets and life as we know it. Conclusion. The life cycle of stars is a testament to the dynamic and ever-changing nature of the universe. From their birth in stellar nurseries to their ultimate fate as white dwarfs, neutron stars, or black holes, stars are the cosmic forges that shape the elements and energy that drive the evolution of galaxies. Understanding this cycle not only deepens our appreciation of the stars that light up our night sky, but also connects us to the very processes that created the matter in our own bodies. For more insights into the wonders of the universe, subscribe to IIRC YouTube channel, where you can explore fascinating topics in astronomy and beyond. Subscribe to IRC YouTube channel today to keep learning and expanding your understanding of the cosmos.